Hello everyone. In this video I am going to explain chemical reactions and equation, chapter 1 of NCERT CBSE 10th. It is also there for a state 10. Okay, so let's start the concepts. Okay, when we talk about chemical reaction is a chemical change. Okay, generally in a chemical change new substance is formed. Okay, so how can you say that chemical reaction has taken place? By seeing its characteristics only we can say the chemical reaction has taken place. So let's start. Okay, chemical reaction. What is chemical reaction? Generally whenever a chemical change occurs, okay, like burning of coal, whenever coal is burnt, okay, we'll get a carbon dioxide, yes or no? So that is a chemical change, or we can say chemical reaction. So there are few characteristics or evidence of a chemical reaction. We can say whenever there is change in a state in the sense solid state to liquid state, liquid to gaseous state. So whenever there is a change in a state we can say that chemical reaction has taken place. Similarly, change in color, evolution of a gas, whenever there is a gas formation in the reaction, okay, in the process, then we can say chemical reaction has taken place. Whenever there is a change in temperature or formation of a precipitate is nothing but it is an insoluble solid which is formed during a process. Is it clear? So this question may be asked for 2 marks. So you have to remember this. Next. Okay, chemical reaction, okay, is represented in the form of a chemical equation. Okay, where whatever the elements or compounds are involved during the process, we are representing in the form, okay, of a chemical equation. So what is chemical equation? The method of representing a chemical reaction with the help of symbols and formulas. Okay, for example, we can see a magnesium ribbon is burnt in oxygen, it gets converted into magnesium oxide. So here we can write a word equation like magnesium plus oxygen gives you magnesium oxide. So generally the substances which react during the process, they are called as reactants, and the new substance which is formed during the process is called as product. Is it clear? So we can write the equation. Magnesium symbol is Mg, oxygen O2, magnesium oxide MgO. Here you can see the definition. Reactants left and generally left hand side with a plus sign. Okay, product right hand side with a plus sign. Okay, in between them may be there, may not be there. Okay, fine. So if there are 2 or more than 2 products, we have to use a plus sign. We can represent a chemical reaction simple and generally chemical equation A plus B gives rise to C plus D. Okay, so where A and B are what? Reactants, whereas C and D which is formed, okay, is called as product or are called as products. Is it clear? Next, we talk about a balanced chemical equation. One question may be asked, why do we need to balance the chemical equation? So you have to answer to satisfy the law of conservation of mass. Okay, what is the law of conservation of mass? We have learnt in 9th standard. According to this law, during a chemical reaction, the mass of reactant is equal to the mass of product, or we can say that mass can neither be created nor be destroyed in a chemical reaction. Okay, so we can see here balanced chemical equation. Okay, why it is required? To satisfy this law of conservation of mass. Mass can neither be created nor be destroyed in a chemical reaction. Or we can say the total mass of the elements present in the product is equal to the total mass of elements present in the reactants. Okay, so generally when the number of atoms present on the left hand side and right hand side for each element is equal, then we can say it is a balanced chemical equation. Is it clear? So number of atoms of each element remains the same before and after the chemical reaction, such is called as balanced chemical equation. For example, you can see zinc plus sulfuric acid gives you zinc sulfate plus hydrogen. So generally we are writing like this: element, first column element, number of atoms in the reactant or LHS side, okay, number of atoms in the product or RHS Yes or no? So what are the elements involved? Zinc, okay, hydrogen, then sulfur, then oxygen. On the left hand side, how many atoms of zinc is there? You can see 1, okay, hydrogen 2 atoms, okay, sulfur 1 atoms, oxygen 4 atoms, okay na. On the right hand side, zinc 1, okay, hydrogen here we can see 2, okay, sulfur as you can see 1, and oxygen we can see 4. So as you can see clearly, the number of atoms of each element on the LHS and RHS, okay, are same. So it is a balanced chemical equation. Okay, in the exam they can ask you write the balanced chemical equation or balance the following chemical equation. So here we can see, okay, generally some steps we are following to balance the chemical equation. So whenever the chemical equation is given, first we have to draw the boxes around each formulas. Do not change anything inside the box while balancing. Second step is what? List the number of atoms of different elements present in the unbalanced equation. Just now we saw, okay, and first next balance the compound that contains maximum number of atoms, which may be from the reactant or product. This is very important step. Okay, first we have to balance the compound which is having the maximum number of elements, okay now, and in that compound select the elements which has the maximum number of atoms. Is it clear? And balance that element and put that coefficient in the box, okay, of 1, and you get a new equation. Similarly, balance the other elements using the equation from 3 and put the coefficient in the equation. And finally we have to examine the above equation and pick up the one which is not balanced. Continue this until, okay, you get all the elements balanced. So that's why it is called as what? A hit and trial method. Okay, by counting the atom of each elements on the both sides of the equation, check the correctness of the balanced equation. Okay, yes or no? So writing symbols of physical states, and the last we have to mention the states also, like whether it is in gaseous state. So for gaseous state we have to write G, liquid state we have to write L, okay, for aqueous state we have to write AQ, for solid state we have to write S, okay, of the reactants and the product. Let's see equation, this balanced equation. Okay, iron reacting with a steam H2O gives you Fe3O4 plus H2. So first you can see they have made the boxes are made here. Okay, here table is created, formed, element LHS, RHS, okay, yes or no? So here Fe plus H2O gives rise to Fe3O4 plus H2. So we can see using this criteria we have to select this first Fe3O4. Okay, we can see which is having the maximum number of atoms, oxygen 4, okay na, yes or no? So here this side is 1. So first we have to multiply 4 on the LHS side to get a balance here. So you can see Fe plus 4H2O gives rise to Fe3O4 plus 4H2, yes or no? Similarly we can see here hydrogen 4 to the 8. So we have to multiply here also 4. So hydrogen also balanced. Now iron is what? Not balanced, which is 3. Here is okay 1. So you have to multiply 3. Okay, in this way we can learn the balancing. Okay, now let's start a very important concept, that is types of chemical reaction. So generally 3 to 5 marks questions may be asked based on this topic. Okay, so when we talk about the types of chemical reaction, so we have generally 5 types: combination reaction, decomposition reaction, displacement reaction, double displacement reaction, okay, and one more is there, redox reaction, which is 5th type, oxidation and reduction. To understand this oxidation reaction, redox reaction, we need to understand the oxidation and reduction also. Okay, so let's start. A combination reaction is generally exothermic reactions are the reaction in which energy is released, okay, whereas decomposition reactions are endothermic reactions, the reactions in which energy is absorbed. Okay, now so we will discuss one by one. Okay, first one, combination reaction. Okay, as the name suggests, combination reaction means here this is also called a synthesis reaction. Here generally 2 or more substances combine to form a single substance. Okay, so combination reaction, 2 or more reactants combine and produce a product. So types of combinations we can see here. Okay, examples of combination: burning of coal, C plus O2 gives you CO2. Formation of water from H2 and O2, you can see 2H2 in the gaseous state, O2 in the gaseous state will form H2O in the liquid state, 2H2O. Similarly, calcium oxide reaction with the water to produce select lime, CaO in solid state, Q-lime plus H2O, liquid state gives you water, select lime, CaOH twice, select lime, that is calcium hydroxide. Okay, combinations reactions are generally exothermic reactions. Okay, exothermic means generally energy is released or heat energy here especially is released. Heat energy is released. Okay. Next, we talk about decomposition reaction. Okay, you can note down the definition. It is a type of chemical reaction in which a single substance breaks into two or more simpler substances. Okay, for example, okay, decomposition of iron sulfate. Iron sulfate, once you heat iron sulfate, it gives you Fe2O3, that is iron oxide plus sulfur dioxide plus sulfur trioxide. So here, what is decomposition reaction? A single reactant breaks down to give simpler products. So example of decomposition we can see iron sulfate. Okay, similarly decomposition of calcium carbonate. Calcium carbonate is CaCO3, also called as limestone. Once you heat, you will get calcium oxide, which is a Q-lime plus carbon dioxide. Okay, gas is formed. So we can clearly see one reactant and two products. Similarly here, one reactant and there are three products. Yes or no? So this is a decomposition reaction example. Okay, so we have a different types of decomposition, especially three types are there: thermal decomposition, electrolytic decomposition and photochemical decomposition. This question may be also asked for 3 marks. Okay, so let's start a thermal decomposition. So thermal decomposition, when a decomposition reaction is carried out by heating, is called as thermal decomposition. For example, decomposition of lead nitrate. Okay, PbNO3 whole twice, lead nitrate. Once you heat, you will get a PbO, lead oxide plus 4NO2, that is nitrogen dioxide plus O2, oxygen is formed. Okay, here very important point you have to remember, what is the color of nitrogen dioxide? It is brown. Here brown fumes is obtained. Yes or no? And as it is taking place with the help of heat, so this is called as thermal decomposition reaction. Similarly, we have other type, that is photolysis decomposition or photochemical decomposition. So when a decomposition is carried out by sunlight, it is called as photolysis decomposition or photochemical decomposition. Photochemical decomposition. Okay, here for example 2AgCl, whenever it is exposed to sunlight, it gives you 2Ag plus Cl2. Okay, when decomposition of silver bromide, AgBr. Okay, whenever sunlight is passed through this, so it will give you 2Ag plus Br2. So these two reactions are also used in black and white photography. They are asking one question. Okay, name two equations which is used in, name two reactions or write two reactions which is used in black and white photography. So decomposition of silver chloride and decomposition of silver bromide. Okay, so where we are used in black and white photography. Is it clear? Similarly, we have one more type, electrolytic decomposition. The type of decomposition reaction which takes place with the help of electricity is called as electrolytic decomposition. Yes or no? So example of electrolytic decomposition, when a decomposition is carried out by electricity or electric current. Okay, for example, electrolysis of water. So water is what? H2O. Whenever two molecules of water in the presence of electricity, it gives you 2 molecules of hydrogen gas and 1 molecule of oxygen gas. Okay, so as this reaction, how many reactant? 1 reactant and 2 products. Yes or no? As this is carried out with the help of electricity, it is called as electrolytic decomposition. Okay. Similarly, next we talk about a displacement reaction. Okay, next we talk about a displacement reaction. Displacement reaction is a type of chemical reaction, okay, generally in which mutual exchange of ions take place. Mutual exchange of ions takes place, okay, that is called as double displacement reaction. In case of single displacement reaction, what happens, okay, a more reactive element displaces a less reactive element from its salt solution. So we can say displacement reaction is of two types, single displacement and double displacement. So let's read first a single displacement reaction. Okay, in the single displacement reaction we are representing like A plus BC gives rise to AC plus B. Okay, this is the representation of single displacement reaction. Here what is the condition? A must be more reactive than B. Okay, so the generally the metal reactivity series can be used to predict the metal will react with a other metal compound or not. So here we have a reactivity series, okay, in which elements are arranged in the decreasing order of reactivity. Okay, so potassium is most reactive. So here few elements you should remember: potassium, which is most reactive. After that sodium, calcium, okay, magnesium, aluminium, zinc, iron, okay, hydrogen, copper, mercury, silver, gold, platinum. So this is the order of reactivity. What happens? This is the most reactive, and platinum is what? Least reactive, and top to bottom reactivity decreases. Okay, so if the metal is more reactive than the metal in the compound, it pushes out or displaces the less reactive metal from its compound. So we can write in the flow chart like this: more reactive element plus less reactive metal compound gives rise to more reactive metal compound plus less reactive metal. Okay, let's take one example. Okay, iron reacting with copper sulfate. You can see that iron is more reactive than copper, yes or no? Because iron is up in the series, so it is more reactive than copper, so it will displace the copper. So what it will form? It will form FeSO4 aqueous plus Cu. Okay, so here one more thing, one more observation is there: the color of solution changes from blue to green. Okay, now this is also important question. Okay, so here one more example you can see. Okay, zinc rod in copper sulfate. As zinc is more reactive than copper, so it will displace the copper, yes or no? So zinc plus copper sulfate gives you zinc sulfate plus copper. Okay, so zinc is more reactive than copper, so it displaces the copper from copper sulfate. So lead nitrate, lead in the copper chloride solution. Lead plus copper chloride gives rise to PbCl2 plus copper. Why? Because lead is more reactive than copper, yes or no? Double displacement reaction, we can just note down the definition please. It is a type of chemical reaction in which mutual exchange of ions take place. As a result of double displacement reaction, generally two new products are formed. Okay, we can represent double displacement reaction like this also: A, B plus CD gives rise to AD plus BC. Okay, like this we can represent. So A here it comes here and C goes here. Okay, so exchange of ions between the reactants. The positive ions, which is called as cation, and the negative ions, which is called as anions, of the two reactants switch places, forming two new compounds or products. So formation of barium sulfate and sodium chloride. You can see sodium sulfate is there, Na2SO4. When it reacts with barium chloride, okay, so what happens? Na and barium exchange their ions. So barium sulfate is formed, plus barium comes here, barium sulfate plus sodium moves here, so sodium chloride is formed. So now this reaction gives a white precipitate. Okay, so a substance which is insoluble in water is called as precipitate. Okay, if a precipitate is formed in the double displacement reaction, it is called as precipitation reaction also. Okay. So here we can summarize also the types of reactions. Displacement reaction, okay, one atom or a group of atoms of a compound is replaced by another atom or a group of atoms, like zinc plus copper sulfate gives you zinc sulfate plus copper. combination reaction, two or more substances combine to form single substance, like calcium oxide plus water gives you calcium hydroxide. Here all the chemical reactions we can see. Next double displacement reaction, reactions in which the reactants ions exchange places to form new product, like copper chloride plus silver nitrate gives you copper nitrate plus silver chloride. Okay, we will discuss one more type, that is redox reaction also. Okay, first try to understand what is redox reaction. Redox reaction is a type of reaction in which both oxidation and reduction takes place simultaneously, that is redox reaction. Okay, what happens? The type of chemical reaction in which both oxidation and reduction take place simultaneously. This is the definition. So you need to understand first what is the oxidation reaction, what is reduction reaction. So let's read that first. What is oxidation reaction? Okay, and what is reduction reaction? See, oxidation, one second, this is reduction reaction. So oxidation reaction is a type of reaction in which involves the following. What it involves? Generally addition of oxygen. Okay, for example, C plus O2 gives rise to CO2. Okay, or we can say there is a removal of hydrogen. Okay, for example, okay, 2H2O gives rise to 2H2 plus O2. You can see with oxygen hydrogen is there, here with oxygen hydrogen is not there. So it is what oxidation. One more you can remember, loss of electron. It is not given in the textbooks, but you should remember. Okay, loss of electron. Whenever it takes place, generally metal is there, like sodium, okay, which is having one valence electron, it loses one electron, it forms what? Na plus ion. Yes or no? So this is also oxidation reaction. Reduction is just reverse of oxidation reaction. Okay, so we can say here reverse of this, addition of oxygen means here removal of oxygen takes place. Okay, for example, 2HGO gives rise to 2Hg plus O2. Here we can see with mercury, oxygen is there, with mercury oxygen is not there. Or we can say here removal of hydrogen is there, means here we can say addition of hydrogen. Okay, for example, nitrogen gas combined with hydrogen gas, it gives you water 2 times of NH3, ammonia gas. So here 3 to the 6 hydrogen is there, you have to multiply. Okay, and one more we can say gain of electrons. Okay, the chlorine atom is there, so 2, 8, 7, it gains 1 electrons, become what? Cl minus ion, 2, 8, 8. So this is also reduction reaction. Is it clear? So the reaction in which both takes place. Okay, when we talk about redox reaction, okay, so in which both takes place simultaneously, both oxidation and reduction takes place simultaneously. Let's take one example, zinc oxide reacting with the coke gives you zinc plus carbon monoxide. So we can clearly see C to CO, there is an addition of oxygen. So this is what oxidation. Okay, zinc oxide to zinc, there is a removal of oxygen. Yes or no? So this is what reduction. So as in this equation, both takes place simultaneously, both oxidation and reduction takes place simultaneously. So it is called as redox reaction. Yes or no? Here one question they may ask you, identify which is oxidizing agent and which one is reducing agent. Okay, which one is oxidizing agent? Generally the substance in the redox reaction which undergoes reduction is a oxidizing agent. So you have to see on the left hand side which is undergoing reduction. Zinc oxide is undergoing reduction. So this is what a oxidizing agent. Okay na? And similarly, what is reducing agent? Reducing agent. So the substance which undergoes oxidation, it is just ulta, children. Okay, the reaction, the substance which undergoes oxidation in the redox reaction is called as reducing agent. So you can see here, this is coke actually. See, coke is undergoing oxidation. So here what is C, that is coke, is a reducing agent. Yes or no? So they may ask you to identify the oxidizing and reducing agent. Okay. So here let's see here redox reaction concepts. Just now, okay, you can note down the definition also. Oxidation is the loss of electron or increase in oxidation state by a molecule or atom or ion. Okay, here, or we can say oxidation is what? Addition of oxygen, removal of hydrogen, loss of electron, or we can say increase in oxidation state. Increase in oxidation state. Generally, oxidation state in the oxidation reaction will increase. Okay, the substance gains oxygen during the reaction, it is said to be oxidized. Okay, so this we can see Fe plus H2, Fe plus O2 gives you Fe2O3. Okay, so iron is getting oxidized. Yes or no? Here, reduction, it is that generally the gain of electrons we can say. Okay, or what we learnt, reduction means generally removal of oxygen or addition of hydrogen or loss of electron. Okay, or we can say decrease in oxidation state. Oxidation state. For example, if you see Cl minus is there. Okay, whenever Cl minus gains one electron, become what? A Cl, chlorine atom. Yes or no? 2, 8, 7. Here 2, 8, 8 is there. 2, 8, 7. So here oxidation state is -1. Here oxidation state is 0. So there is a decrease in oxidation state from -1 to 0. Okay. So this is all about the types of chemical reaction. Okay, types of chemical reactions. We have some miscellaneous concepts. Let's see. Okay, here summary is there. We can see the summary, chemical reaction, the types of reaction. Okay, two more topics I want to discuss with you. What is rancidity and what is corrosion? Let's see. Okay, we talk about rancidity. Okay, so you can note down the definition. The process of oxidation of oily and fatty food items which result in their bad smell is called as rancidity. What happens whenever the chips packet or the cooked chicken is left out for few days, so some bad smell will start coming out of it. Yes or no? So why? Because the fatty acid present in them get oxidized. Okay na? So we can write the equation for rancidity also, like fat or oil react with oxygen, it gives a rancid product. Rancid product. Okay, rancid product. This is the equation we can write in short, or we can write the definition. It is the process of oxidation of oily and fatty food atoms which result in their bad smell. Okay, so there are some methods to prevent it. You should remember methods to prevent it. Okay, first one is what? By flushing the food items in the presence of nitrogen. For example, in chips. So we can write by flushing with a nitrogen gas. Second one, generally what happens that rancidity or oxidation of fat does not take place in the at the low temperature. So by keeping the food atom in the refrigerator. Okay, that is the second step. Third step is what? By using antioxidants, chemicals. Okay, and fourth step we can write by airtight container or vacuum packing we can say. So 4 steps you have to remember. First one is what? By flushing with nitrogen gas. Why? Because in the presence of nitrogen oxidation cannot take place. Okay na? Next, by using antioxidants. By using chemicals, preservatives we can say. Example you can remember BHA, BHT. Okay, butylated hydroxyanisole, butylated hydroxytoluene. So these are the example of antioxidants. Third we can say by using refrigerator. Okay, and the fourth steps we can say by airtight container. Okay, this question may be asked for 2 to 3 marks. And the last concepts in this chapter is corrosion. Okay, what is corrosion? It is nothing but a process of destruction of metal surface whenever it is exposed to air, water, acid, etc. Okay, so just let's see corrosion. Okay, example of corrosion is what? Rusting of iron. You can note on the definition. It is the process of destruction of metal surface whenever it is exposed to moist air, okay, moist air, acid, bases, etc. Okay, for example we can say rusting of iron. Rusting of iron is a very good example. Rusting of iron. What happens whenever iron is exposed to the air and water, that is moist air, so O2 plus H2O, it will form a hydrated ferric oxide. Brown flaky layer is obtained, that is rust. Fe2O3 dot XH2O. Okay, similarly we have a corrosion in silver. Silver article Ag react with H2S, hydrogen sulfide, it gives rise to Ag2S plus hydrogen. Here black coating is obtained, silver sulfide. This is what a brown rust. Okay, sometimes they may ask you what is the formula for rust. Okay, Fe2O3 dot XH2O. Okay, silver water compound is formed upon rusting. So silver sulfide Ag2S, black color. Similarly, rusting or corrosion takes place in copper. Copper in the presence of O2, CO2 and H2O, it gives a basic copper carbonate, green color, CuCO3 dot CuOH twice. So here green coating of basic copper carbonate is formed. Okay, one more question they may ask you, how can we prevent corrosion? So we have various methods like painting, oiling, greasing, galvanization. What is galvanization? The process of coating a layer of zinc, okay, on iron article is called as galvanization. Okay, so you can note down few, they may ask for 2 to 3 marks methods to prevent corrosion. Again, this chapter is there in the metals and this concepts is there in the metals and non-metals also. Okay, here how we can prevent by painting is one method. So you can see that iron articles are painted to prevent it from corrosion. Okay, painting, oiling is also one of the method. Greasing and galvanization. Okay, they may ask you in MCQ question, the process of adding or depositing a layer of zinc. Process of depositing a layer of zinc, on iron article, is called galvanization. Okay, I hope you understood these concepts. Please share with your friends and subscribe the channel. Okay, thank you.